The sequence n of natural numbers is divided into classes as follows. So here we have the class 1 that contains two natural numbers 1 and 2. The next class contains the natural numbers 3, 4, 5, 6. Next class contains the natural numbers 7, 8, 9, 10, 11, 12, and so on. Our goal will be to determine the sum of the numbers found in the nth row only. Okay, let us begin. So first let's list out the number of terms present in each of the class, or we can say each of the row. So the number of terms in the first row, that's equals to 2. And we can also express 2 as the product between 2 and 1. Next, the number of terms in the second row, that's equals to 4. So we have 3, 4, 5, 6. So there are 4 terms in total. So this can be also expressed as 2 times 2. Then we come to the third row, the number of terms in the third row, that's going to be equals to. So here we have 6 terms in total that can be expressed as 2 times 3. Now, if we continue, then we will observe that the number of terms in the nth row, that's going to be equals to 2 multiplied to n. Next, we try to find out the total number of terms present up to the nth term. So what's the total number of terms that's present up to the nth term? So that's going to be simply equals to, we're going to take the sum. So from the first row, we have 2 times 1 terms. This will be added to the number of terms in the second row. So that's 2 times 2. The number of terms in the third row, that's 2 times 3. This goes all the way up to 2 times n. Now, here we have to find out the sum. Now, we know that sum to n terms, we have a standard formula for this. That's given by n over 2 multiplied to 2 times a added to n minus 1 times the common difference d. Or the other way is we can take number of terms divided by 2 multiplied to the first term plus the last term. So here in our case, we have n number of terms, so divided by 2, this will get multiplied to the first term, which is 2, added to the last term, that is 2n. Simplifying this, we get n squared plus n. So that means there will be a total number of n squared plus n terms that's present up to the nth term. So what we'll do, we'll also calculate the total number of terms, present up to the previous term of nth term. The previous term to that of nth term, that is simply n minus 1th term. So what will be the number of terms, total number of terms present in up to n minus 1th term? All we have to do is replace n in this sum that we just obtained with n minus 1. So that means we have n minus 1 whole squared added to n minus 1. So this is going to be equals to, now we have n squared minus 2n plus 1 added to n minus 1. So when we simplify this, we have 1 and 1 cancelling out, n squared. So negative 2n plus n is simply going to be negative n. Now that means we have up to the second last row, or I can say that up to the n minus 1 term, that will be n squared minus n. Now let's go back to our problem. What we have to find out? We have to find out the sum of the natural numbers found in the nth row only. So what we will do to find out the sum of the terms found in the nth row only, so what we'll do, we'll take the total sum. So we will take the total sum of all the terms starting from the first row all the way up to the nth row, and then from here we're going to take the sum of all the terms from the first row up to the n minus 1th term. So that means we have 2 times n minus 1. So when we subtract the sum, this is only going to leave us with the sum of the terms found only in the nth row. Okay, so let's try to figure that out. So we have already obtained the sum of the natural numbers up to the n of nth row. So we'll take the summation of k. So this gives us the sum of the natural numbers. Now, whatever does k runs from? K runs from 1 up to the last term of the nth row. So we have already obtained the total number of terms present in the nth term, that's n squared plus n. So that means our sum, the index k is going to run to n squared plus n. And from here, we're going to subtract the sum of all the natural numbers, where k index runs from 1 to the n minus 1th row. So here from to the 1 minus 1th row, we have total number of n squared minus n terms. So k goes from 1 to n squared minus n. Now we will solve this. Now we know that if we have summation of k, this means sum of all natural numbers from 1 to n. This has a standard formula given by n times n plus 1 over 2. However, in our case, we have total of n squared plus n terms. We don't have n terms, but we have n squared plus n terms. So that's okay. What we will do, we only have to do is, in this particular formula, we'll replace this n value with n squared plus n. So we have n squared plus n multiplied to, we need n plus 1. So that means we need n squared plus n plus 1 divided by 2. Minus, again we have the summation of natural numbers going from 1 to n squared minus n terms. So we'll replace n with n squared minus n. N squared minus n multiplied to n squared minus n minus 1 whole divided by 2. Okay, so let's further simplify. So n squared plus n multiplied to n squared plus n plus 1, that's going to be n raised to the power of 4 plus n cubed plus n squared. Added to, now we'll multiply n with n squared plus n plus 1 to get n cubed plus n squared plus n whole divided by 2. Minus, now we have n squared times n squared minus n minus 1. So that's n raised to the power of 4 minus n cubed minus n squared minus n cubed plus n squared plus n whole divided by 2. Now we'll further simplify. This is going to give us n raised to the power of 4 plus 2n cubed plus 2n squared added to n whole divided by 2 minus n raised to the power of 4 minus 2n cubed and then negative n squared, positive n squared. This gets cancelled out, leaving us with plus n whole divided by 2. Furthermore, we're going to combine them, and then in the numerator we have n raised to the power of 4 plus 2 times n raised to the power of 3 plus 2n squared plus n minus n raised to the power of 4 plus 2n cubed minus n whole divided by 2. The n raised to the power of 4 gets cancelled out, n also gets cancelled out. That leaves us with 4n cubed plus 2n squared divided by 2. Now we can factor out 2 from the numerator and the denominator. So we have 2n cubed added to n squared. So if we take n squared as the common factor, so we have n squared multiplied to 2 times n added to 1. So this is going to be the sum of the terms that's present in the last row. That means in the nth row only.